Look at some of the common problems people have while doing math problems involving the work-kinetic energy theorem. Now, here's the issue that people are going to run into more than anything, is that when you look at the work-kinetic energy theorem, it seems very simple with this equation right here, that the work that is done is going to cause a change in the kinetic energy of any system. And it is true that it's pretty simple. The problem is, depending on what information you're given off of the problem, the format of this equation could take a number of different directions. So, let's say, for example, instead of being given straight up how much work is being done, unfortunately, you're instead given a force, a displacement, or with some angle. If that's the case, then we're going to have to replace this work with the overall equation for work in order to solve what we need. Now, the same thing can go for changing kinetic energy. Now, anytime we see a change in, it always means that it's going to be our final minus our initial. Okay, and that could be the case that they have. They give you the amount of kinetic energy something has, or you've roundabout found it in a different way. Let's say that you found how much kinetic energy you have by traveling in a vehicle and ask you how much you would lose. Well, you have that value, you're able to work through it. So it might be replacing it with final minus initial. Or it could also mean that we go back with masses and go all the way back to this format of the equation. So as simple as this one seems to be, depending on what information you're given, it could end up taking a number of different forms. This equals this equals this, or this equals this equals this equals this, or this equals this. So this one equation can really take 6 different potential forms based upon what information you're given on your problem. So that is probably going to be one of the biggest challenges that you're dealing with here. So as you're looking at this, it really comes down to, what are you given? And what do you need? Okay, so you really need to answer or ask those questions of yourself as this problem begins to figure out what format or what alignment of this equation you're going to have to go with. So you need to think that way right off of the start. In the previous video I did, we were talking about car stopping distance. Well, the problem is, when you're talking about car stopping distance, obviously we need to go into this format here. And when I said it's based on the speed of the car or the velocity, that means we can't go here, we can't go here, and we can't, well, we're going to have to go here as the end result. So it really is going to come down to your ability to identify what variables you have, what you need, and where you need to go from there. The math is not all that challenging. It's really going to come down to one of these iterations of these equations, all of which you're more than capable of doing. It's just really a question of which format's going to work for which problem.